So if we think back to when we first started studying waves, we looked at all of these different characteristics that a wave had, and then we specifically applied it to mechanical waves and sound. And now we're going to look at how light demonstrates these wave properties. So this is a list. Some of them you will recognize from before, some of them may be new. So we have reflection, diffraction, transmission. Refraction is a new one. This kind of has to do with transmission when we talk about light. Interference, and the Doppler effect. So all of these characteristics can be observed because light demonstrates wave properties. So in this video, I'm just going to start by talking about the first one, which is reflection. But before we talk about reflection, we need to recognize the fact that when we are going to be dealing with light as a wave, we most often will deal with it as a ray or treat it like a ray. So light has a point of origin where it began and then where it is arriving. And so we draw it with an arrow or a vector to represent the path of the movement of light. And we call that a ray or a light using a ray model. So let's look at what this looks like in terms of reflection, and then I'll give you an equation. So when light travels towards a surface, so this is a reflective surface, it could be a mirror, this background image you can see is a lake. These lines right here represent rays of light coming from light source, some light source over here. And so you can see they have a direction. And we call these the incident rays because these are the rays that strike or are incident upon this surface. Then the rays that bounce off the surface and go back into wherever they came from or the medium from which they came, those are called the reflected rays. So this is right here is the surface or the interface. Now, wherever the light ray strikes the surface, there is a line that runs perpendicular to that surface. You can see here this light ray strikes this surface, and then there's a line if we were to draw a 90-degree angle or perpendicular to the surface there. That is called the normal line. So the normal line runs perpendicular to the surface. Now, the law of reflection for flat mirrors is really easy. It is that the angle of incidence is equivalent to the angle of reflection. But it's important that we just define what that angle actually is. So the angle of incidence is the angle between the incident ray and the normal line. So it's actually this right here. It is not the angle to the surface. It's the angle to the normal. So then the reflected ray would be the same. It would be from the reflected ray to the normal. So you can see here as it comes in, this incident ray comes in and it bounces off. Then this angle here and this angle here would be equivalent to one another. So that's basic reflection for flat mirrors. We'll look in the next videos on how to identify where images are located and how they appear based on looking at mirrors that are either or reflective surfaces that are either concave or convex.